Hi everybody, just a little video here to accompany lab 2 where you have to check a diode to see if the diode is good, and so you are going to take some readings from a diode using the diode check of your multimeter. So you can see on the bottom screen there I have a pile of light emitting diodes, LEDs, and then I have a pile of regular diodes similar to what you should have in your parts kit that that are not LEDs. Okay, so just regular diodes here, LEDs over here. On the top screen there, you can see my multimeter, and if I turn my multimeter on, so green button here turns the multimeter on, and then the other two buttons I have depressed here are the kilo ohm button and this setting here. You can see that both of those have the diode check symbol above them. So that is, these two buttons here are the ones that I'm going to press for the diode check, and they have the little diode check symbol there. I have my red lead in the volt ohm connection, and I have my black lead in the common. Those are the same two leads you see down here in the bottom screen. Okay, so to check my diode, I want to identify the anode and the cathode. Remember, the cathode has the bar on it. So if I take this diode here, the bar is here on the right side, so that's going to be the cathode. I have the anode and cathode. If I forward bias, so this diode, I can see if it's working or not from the meter reading. Now, on the diode check setting, the meter is going to put a small current through this diode. If I've connected the leads with the red lead to the anode, black lead to the cathode, I'm going to forward bias this, and you can see what sort of reading I get. So let me forward bias that diode, and you see on the meter above there, I get a reading of 0.582. That is actually a tiny, a small forward voltage for this diode that is displayed during this test. Some meters don't display a particular voltage; they just give you a reading that you can see. Okay, it's okay, but in this case, it is a small forward voltage. Now, notice that when my leads are not connected to anything, my meter displays 1 dot. That's what my meter displays for an open circuit condition. So if I swap my leads here and I reverse bias the diode by putting positive on the cathode side, like so, you can see that the meter stays with that open circuit display, and that's actually what we expect from the diode, because if we forward bias it like so, we want it to turn on, and I can see that it would be on with this small forward voltage. And then if I reverse bias it, I want it to act like an open circuit, which it is. So I know this diode is good. I don't have a bad diode to show you, but if a diode was bad, it would show, if it had failed open, it would show open circuit no matter which way I put the leads, and then you would know that the diode is bad. Okay, I can also use my meter to test LEDs, even though that's not the main use of this setting, but it can be used. So you can see with this light emitting diode here, that that it has a higher forward voltage, which it does, and I can see that this diode is on. I'm trying to show you that this light is on. It's a little bit hard to see. If I turn that light off, you can see there that this diode is on. So I know that this diode is working. And then again, if I reverse bias this diode, I have the open circuit, which is correct, right? Now I can do this also for yellow. and you can see that the yellow diode there, if I turn this light out, you can see the yellow diode is on, and I've got that reading on my meter above. Now, if I try to go to something like a blue LED, I'll show you what happens, because this setting wasn't really made for testing LEDs. The forward voltage of a blue LED is actually higher than the two display of this scale. So when I forward bias it, you can see the blue LED is on, but I only get a reading for a second and then it goes off scale. But the LED is on, so I can see that it's working. And if I turn this light out, I don't know if you can see the blue color any better, but that's a blue LED. So, so that's how I can use my meter to check if a diode is good. Now, if you don't have a test equipment meter at your house, then you could also use a handy dandy little Mastercraft meter, the kind you would buy at Canadian Tire. And I can change this to the diode test setting here. And you can see with the leads open, so here's my two leads and they're open, the meter is displaying just a 1, so I know that's my open connection. And if I reverse bias, now I've got a different little tiny diode here where the black bar is the cathode. So right now it's reverse biased and it shows open, that's correct. And if I forward bias it, I get a reading. It's not displaying it as a voltage, but I get a reading, and so I know that this diode is in fact good. Okay, so take note of that to fill in your Lab 2 results. And also, you know, it's a good idea to take a look in your parts kit, see what parts you have. You know, all the parts like these diodes are going to have a part number on them. So you can read it easier if you shine a light on it. But they have a part number, and you can look up the different specification sheets for each of these different components. Okay,